All right, balancing equations here, folks. Excuse me. So when we look to balance equations, again, the big thing that we're looking for here is we want to know how many elements or how many atoms of the elements do we have on each side. So if we look at it, we've got Al and we've got Br. Okay. On the left side over here, the reactant side. So this is our reactant side. Okay. We've got one Al and we've got two Brs. On the product side, we've got two ALs and six BRs. All right. So what I start to look at is, all right, how can I get that AL to be from 1 to 2? So what I'm going to do is multiply that by 2. Okay. By doing that, I get 2 over here because 2 times 1 is 2. All right. So I put that 2 right there. Now my ALs are both good. All right. My BRs, right? 2 to 6. Well, I can multiply 2 times what to get 6? Well, that's going to be times 3. That's going to equal 6. Now, here again, I'm going to write the 3 up there. So what you're seeing is I'm writing the 2 there. I'm taking and writing the 3 up there. All right. By doing that, I didn't change anything else. That would be a balanced equation there. Okay. H2O, making H2 and O2. All right, so I've got H and I've got O. Left side, I've got two H's and one O. Right side, I've got two H's and two O's. All right, so if I look at my left side, I know I need to multiply by 2 on that O. Now, here's the issue, right? There's an H2 in front of this O. So I cannot, so I want to double that O, but I cannot put the 2 right there. All right, that doesn't work. All right, so what that means is then I have to put it in front of that H2. All right, by doing that, all right, I messed up my H's, right? My O's, they're solid. But by putting this 2 here, this 2 goes to the H and also to the O. So 2 times 2, so this instead of being 2 is going to be 4. Now, if I look over on the right side, I've only got 2 there. So I need to put a 2 there. So I'm going to multiply this by 2, and that's going to equal 4. So right there, I've got a balanced equation. All right. The tricky bit with that one was when I went H2O and I had to have a 2 for my oxygen, I could not put it right like that. Okay. AlCl3, so 1 Al and 3 Cls. Over on the right side, I've got 1 Al and 2 Cls. Okay, so now I get my odd even dilemma, right? So in this case, I want to make everything even. So I'm going to multiply this by 2, right, to give me 6. Here again, I cannot go Al2Cl3 like that. That just doesn't work. All right, so I have to put it in front. By putting it in front, now that applies to the Al and also to my Cl3. So that what that means is I've actually got 2 Als there. All right, we look over to the right side. Uh, 1 Al over here. I'm going to multiply that by 2. That gives me 2 there. So I put my 2 up there for that one. Multiply this one by 3 to get to 6. So that means that 3 goes right there. All right. Here the trick was, again, taking this even number here, the 3 versus the 2, and just doubling it. Try and get it so it was even so it would make a little bit more sense. All right. Last one for you here. LiO or Li2 O plus K yields Li plus K2O. So I've got 2 Li's, I've got 1 O. I've got 1 K there. I've got 1 Li over here, 1 O, and 2 Ks. All right, if we start from the top, all right, I got to take this Li, multiply it by 2 to try and get it up to 2. All right, that means the 2 goes right there. By doing that, I don't change anything else because the plus sign stops me. All right, O's are good. Got to fix my K's. I'm going to take that times 2. All right, that's going to go up there for my K. Again, the plus or the arrow stops that. So what ends up happening is I got 2 and 2. That number went up. 1 and 1, that one's good. 2 and 2, and I put that number up. That would be a balanced equation. All right. We'll talk more about it tomorrow as we get there.